Okay, hello everyone. As Alex mentioned, I'm Maya. I'm a PhD student and research assistant in civil engineering at the University of New Mexico. And today I want to talk about LM1, a novel liquid metal of high density and low viscosity at room temperature. So first, I want to start with our team members. Our team is consisted of myself, my colleague Ishtiaq Anwar. We are both PhD candidates and we are founding members and inventors of LM1. And both of us have more than 10 years of experience in research and industry. Ishti currently works at both UNM and Los Alamos National Labs as a researcher, and I myself work at UNM and because I'm a civil engineer at a consulting engineers firm in New York remotely. Our technical lead and mentor is Dr. John Stormont, who has more than 30 years of experience, and we are all from the Department of Civil Engineering. So this LM1, if I want to just give a summary, we have already filed a provisional patent for that. Last semester, we received the National Science Foundation's Innovation Core funding. And we have also won the top prize for the Spring 2021 Rainforest Pitch Competition. Actually, since this is a short presentation, I will balance between the technical aspects and our stand in the market right now, because that's what we did in our I-Core program. And I know that there are both technical and industry audience here today. What is the problem actually? Why did we come up with the liquid metal LM1? Actually, the market for liquid metals right now is huge because there are a variety of purposes that the liquid metals need to be used for. For example, tooth filling material, like contains a certain percentage of mercury, which is one of the known liquid metals, but this liquid metal is toxic to human, as you know. And other liquid metals are available, like metal alloys for usage, they're available, like woods metal, fields metal, but they require an external heat source and higher melting point, which is not possible for specific applications. Most of them react with the moisture in the air and oxidize, and some of the liquid metals, even though they're liquid, they're so thick and they're so viscous that they don't serve the purpose of flowing into the areas that we need them to. And finally, most of them are pricey and not conveniently available. So for all these problems that we posed in the previous slide, we came up with a solution, and that solution is LM1. LM1 is liquid at the room temperature, so it doesn't need any external heat source. It becomes hard like steel at little lower temperatures, which this temperature is actually adjustable based on the application. We can do that. It is not toxic, so it doesn't pose any risk to the human health. It has very low viscosity. It's even less viscous than water, so it can easily flow into very tight spaces. And as you can see in this picture, it doesn't react with the moisture in the air because, as you can see, there is no oxidized layer formed on top of the liquid metal, which has been out like this, like for a while. Finally, it's the price, which is only 30 cents per gram. So here, I want to talk about the initial journey of LM1, which started at UNM. So it was actually based on a project for Department of Energy. Here you can see a sample of a fractured sandstone. They sent us this sample and they asked us to repair it. We placed the sample in a pressure vessel and we applied like a pressure of around 2000 PSI. And then we injected the LM1 into the fracture, and on this picture, you can see like how the fracture was repaired. What is amazing about LM1 is that it can also flow under like high pressures, which is useful for petroleum companies that have reservoirs at high depths in the ground. Here, I want to talk about some of the major applications of LM1. We can say that LM1 is like a robotic material. We can control how viscous the liquid state would be and at which temperature it should turn to solid. For these properties, we have explored some of the major applications. So first of all, because of these properties of turning to liquid and solid and like being conductive, it can be used for different electronic and electric components like flexible wires, semiconductors, self-repair conductors for microchip. And because it has a very good flowability, as I mentioned, it has a very low viscosity. It is very ideal for repairing cracks. For example, it can be used in underground storage and tunnel cracks, and also in car wheel rims. And also because it has high density and higher heat capacity, it can be used as high performance reusable coolant for like new generation nuclear reactors. And it can also be used over and over. And finally, in the medical industry, it can be an alternative to toxic mercury. And because of its high density, it can also be used as ultrasonic gel for ultrasonography. So as I mentioned, like we started with the funding from I-Corps. And with the funding from I-Corps, we have done some market research and found the application and potential markets for LM1. So we have listed them here. The first one is the national and commercial laboratories. They expressed interest in using LM1 as a replacement of mercury because they perform a lot of tests with mercury on their like samples, like different porous samples. And we have been approached by some governmental agencies. The usage was classified advanced tactical military instrument, which was very interesting, but unfortunately, I cannot go into more detail about that. And as I mentioned, in the servers and reactors, metal welding this industry, medical industry, and electronic industry. And another application that we found was do-it-yourself customers for like repair material and lubricant. So here is the market size that we found for each of the applications that I mentioned in the previous slide. Right now, we intend to approach different markets simultaneously because the usage of this LM1 is very wide. So we want to all get and then one, or should we like enter them all together? So here is the total explored market as of June 2021, which was $18.6 billion. From this amount, we understood that $7.4 billion is right now the total accessible market to us. Actually, this product is so new and can be used in so many different kinds of markets that we're still learning what is the application and what the size of those markets are within total. And we are still interviewing with people and different corporations. And this is some of the corporations, research labs, and governmental agencies that have expressed interest in using LM1 for different purposes. For example, the Boring company here is owned by Tesla, and they were interested in using LM1 for repairing some cracks in the tunnel linings. And so what I should say about LM1, like current status, is actually it's already in the manufacturing stage. We can even produce it in our lab currently. And our revenue from LM1 through projects for different customers like Department of Energy, Sandia National Labs, Los Alamos National Labs regarding like different oil and gas projects, hydraulic fracking and crude oil well bores and geothermal wells. It was, so the projects that were using LM1 mainly, it was about 200K just last year. Here is our roadmap for entering our products to the market and giving it to the customers. It covers a period of January 2021 to June 2023. We are currently in the testing the product to find various viscosity and temperatures of being liquid and solid. With changing the composition and even the method of mixing for different applications. And we actually have different ways of going into the market. Once we have the data that demonstrates that LM1 works in all these different applications, then we can either license out or hire someone else to manufacture it for us. We still don't know. But what's interesting for us is that there's been a great deal of excitement about what we're doing. And right now we are working with the Lower Rainforest Innovations on licensing. So we're hopeful. And our stand right now is that we are working with Alex and Arlene at the Rainforest. We think that right now we are doing fine working with them, but we also have been approached by some venture capitalists, big companies and individual investors, but we continue to interview more and talk to more people. And here I finish my presentation. If you have any questions.